showed you simple structures, MS-DOS, Unix, layered. I told you all these type of systems. So I told you that initially operating systems were very simple, not modular, not layered. This is a simple MS-DOS structure. There are no layers. It's only a kind of an interconnection of some components. But slowly we moved to Unix-based system. The concept of layers came. More or less, the layer concept came. You can have multiple kernels. I told you the kernel is like the system interface between the hardware and the operating system, and multiple kernels were possible. Multiple shells were possible. You can have different shells. I told you, you did a lab assignment on Linux. I told you certain commands were not working. Like, in my VirtualBox system, the Linux thing was not working. Tree was not working because it's probably a different shell. So different shells are there. Slight variations are there in the commands. And I told so from Unix this layered structure came, and the layered structure developed into in higher versions of Unix, went into a totally layered structure. Now today almost everything is layered, and there is also a possibility of having microkernels. Rather than kernels, you can even have microkernels. Mac, what is that? Darwin Mac OS is an example of a microkernel structure. Unix also today, the high-end versions like Solaris have got a totally modular approach, and these are also supported by object-oriented systems. OOPS. You can also now combine, you can have layered plus modular, you can have microkernel but different shell. All these possibles are possible today. And I also told you about the iOS, that is the Apple and the Android. And finally, today we will see what is known as a virtual machine. A virtual machine is a very, very easy, interesting concept. Now, you know that you have a hard disk. You partition your hard disk into C drive, D drive, E drive, right? You are partitioning your hard disk into C drive, D drive, and E drive. But actually speaking, there is no partition so as to speak. There is no physical partition so as to speak. They are physical, there is no physical C drive or D drive or E drive. Actually, we are doing a virtual kind of partition. So similarly, we can also partition a computer into virtual machines. So it is a layered approach. A single computer can be converted into different execution environments, creating an illusion that each environment is like a virtual machine or an individual computer. And we think that each virtual machine has its own processor, has its own memory, has its own process. But actually it is not so. It is one single system that has been divided into 3 or 4 virtual machines. Now, this virtual machine is the precursor of what we know as virtualization, which is the background of cloud, right? So that kind of illusion created by the operating system, that each process has its own processor with virtual memory. And how is this managed? It is managed by a virtual machine manager or hypervisor. This hypervisor provides that kind of interface. Now let us just see how a single computer is. You have hardware, you have the operating system here, and here I put it like a kernel, and you have processes. But in the case of a virtual machine, you will find out the same hardware is there, but the kernel is kind of divided into separate microkernels. There is a hypervisor or a virtual machine manager that manages each process in parallel. So the hypervisor has separate kernels, separate processes, and so on. And this kind of microkernel approach is there. There is a virtual machine manager, VM1, VM2, VM3, and these kind of parallelly the hypervisor gives the virtual machine manager gives the idea that this is a separate process. There is a processor for this, there is a processor for the second one, there is a processor. So that kind of illusion is created by a virtual machine. Now, this is very, it started, virtual machine started in the IBM mainframes, and now, it developed into cloud. Now there are a lot of companies making virtualization software like VMware, Zen and all. Vmware is got a very good virtualization technology, and they are now, you have so many servers also, you are able to break that server into different types of virtual machines and so on. And uh, another advantage of the virtual machine is that, see, if one virtual machine breaks down, some problem happens here, the others will continue. And there is also another major advantage, that we can have different kernels here. What I'm trying to say is, just think of this may be a Windows machine, this may be a Linux machine, this may be a Solaris machine. So you can have different configurations also, right? Just hold on for a minute. I'm sorry, I had to stop. Sorry. Yeah, so as I mentioned, have different types of operating system kernels here. We can probably even have different types of operating system. We can have a Linux box, we can have a Solaris box, we can have a Windows, like a dual boot. You know, many of your computers have got dual boot. Dual boot means this kind of dual booting is available. So these kind of options are all available, and they are the advantages of having these kind of virtual machines. You can develop, you can have clones also, you can have a master slave relationship. You can run multiple different operating systems, you can consolidate the memory, you can have virtualization. Also, all these things gave rise to cloud computing. So the basic what should I say, the basic genesis of the virtual machine developed into the cloud computing. And virtualization is a very good application. That way we are able to have multiple processes, multiple, the operating system creates an illusion that each virtual machine is like a separate one. It has its own apps, it has its own resources, has its own memory, it can share the memory, it can have a distributed memory, it can have all options are there. It can have one example is Oracle has something called containers or zones, where the each zone is a virtual layer between the OS and the app. OS and devices are virtualized, providing resources within the zone and so on. So this is the example of that thing. I'll just call you back in a minute. I'm in a class just now. 2 minutes, I'll call you back. Yeah, so that is the kind of, you know, Solaris has this kind of zones. Each zone is like a different thread or user programs, system programs, the CPU and so on. So this is the idea. Another example is VMware. VMware is very popular for virtualization of servers, dividing the servers into micro servers, dividing computers into, you know, hosts, thin clients and so on. You might have heard about thin clients also. VMware also, if you see, you know, you can have different operating systems. See, host operating system is Linux, but here there is a Windows NT operating system. Here there is an XP or Windows operating system. Here there is a free BSD operating system, which is nothing but another flavor of Unix. So this kind of possibilities are there. Another example is the JVM or the Java Virtual Machine, where you are having operating, you know, you have this Java classes which can be reused again and again, and so on and so forth. So I'll close for today. That's all for today. We'll have a lab session today for some more commands in Linux. Again, today you'll have to submit 2 o'clock. By 4 or 6 o'clock you need to submit the commands. I'll take class at 2 o'clock for some time. There's one absentee. Who is that absentee? Can you tell me who is the absentee? 35 is the 36 is the strength. Oh, I'll have to take attendance. Answer your attendance. Ardra, Aaron, Ashika. Raise your hands. Abhay, Aishwarya, Akash. Akash. Okay. Anjali, Ankita, Anne Maria. Okay. Arundhati, Ashwin Anand. Ashwin Anand. Ashwin and Ashwin Anand.
The Ashwin has gone to the hospital, sir. He won't be attending.
Okay, they are absent. Okay. Bhavana, Dhanushri, Dhruva. Dhanushri. Dinesh Kirtana Priya Krishnendu. Krishnendu. Kritika Lakshmi Malavika. Niveda Pranav Kannan Prashant. 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 Yeah. Sri Bala Satyan Shivada. 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 Smriti Sridhar Amrit Subodh. Okay. Varun Chinmaya Pavan. Varun. Varun. Nayana Dhanushka Sri Lakshmi. Varun is present. Okay. Chinmaya Pavan Nayana Dhanushka Sri Lakshmi.
Hello, sir. I am Ashwin B, sir.
Where were you?
Sir, actually, I have a network glitch, so I was not able to. I am present, sir.
Okay.
Last time also this happened.
Okay, sure. Okay, that's all for now. I have a couple of announcements. So today we will have a lab session. Today, 2 o'clock. By 6 o'clock, you are required to submit the snapshot like last time. It may only take you half an hour to 1 hour to do it. Anyways, I'll give you more time. I want to conduct a quiz on Friday on this second chapter. I hope it is okay with you. We got a lot of holidays. I didn't take class because of NAC for a week, 1 week almost. So this Friday you will have this chapter 2 quiz during the class. So there won't be any class that day. Only the quiz will be happening. Tomorrow we will meet with the next chapter on processes. I believe your midterm is only starting on 15th September. So we have enough time. I thought it was 2nd September, but it is only on 15th September. So we will see and wait and watch. Okay. Okay, that's all from my side. See you. Bye.
Sir, Dhanushri is also having a glitch.
Now it's already marked. Next time you tell me. I'll make the change later. It doesn't matter actually. Okay, sure. Bye.
Thank you, sir.
Bye.
Thank you, sir.
So,
Thank you, sir.
Friday we'll have the quiz. Bye.
Thank you, sir.